I used FashionMNIST dataset, and for this project, I have chosen this dataset because of the current demand of image processing, of image-based machine learning in the current market, and it also helped me fulfill the two criteria for bonus marks. That is, one is my data set is higher than 20,000 samples and I ran everything in cloud. Excuse me. And my objective was to explore the multi-class classification algorithm in the context of images, identifying challenges working with the large data set, hyperparameter tuning of different classification algorithms. And number four is impact of the dimensionality reduction on classification algorithm and implement convolution neural network for image classification, implement a random forest for image classification, and run everything that is run every algorithm in GCP. I began with the line pip install keras, that is mostly applicable to cloud. This line is mostly applicable to cloud. Went on importing the necessary libraries, loading the data set. I'll quickly go over the code and so that I can say more about the findings that I had observed. And then I splitted the data set into features and labels, and then I tried cleaning the data set, but fortunately saw there are no null values in the data set. Then I combined the data set with the function np numpy function np.concatenate, finding out the unique labels that I had from 0 to 9. Then I created an array to map label integer to string, verifying if items are correctly mapped to labels by picking 20 random samples. 20 random samples looks like this. Then I went on doing PCA. I applied principal component analysis on the training dataset to identify the minimum number of components that are needed to explain the 99% variation in the dataset. The number of components reduced by 300 features to 440 components. Then I applied the image compression for a reduced dataset, splitted the data into train, validation, test. So here I would like to say that we are splitting the data train set into two more parts. One is train, one is validation. The test will be used at the end to compare the models that we develop based on the train and validate dataset. Also, we will here to normalize values per pixel, that is 28 by 28, to represent a value within 0 and 1. So here I did that. Then I went on defining functions which are matrix generator and then which is matrix generator and generate confusion matrix. So if I implement matrix generator function, it will give me the scores for evaluation purposes, needed for evaluation purposes of different models. And this function generate confusion matrix will give me confusion matrix for training and test for different models. Then I went on developing a baseline model of logistic regression on the non-PCA dataset, on the non-PCA data, and implemented the function generate confusion matrix on the training, on the test data, and then went on doing the same thing with the PCA data, confusion matrix for training, for test, and then developed the K nearest neighbor classifier, KNN model with non-PCA data, confusion matrix for training for test, developed the same thing for with PCA data, confusion matrix for training and test, then developed convoluted neural network classifier, had to reshape the data, getting the CNN model for training for test, confusion matrix. Then with the non-PCA data also, I did the same thing, confusion matrix for training for test. With PCA data, random forest classifier, creating random forest for the training for the test confusion matrix. So here what I did is I tested all generated models against the test dataset, and because the reason I did this is I wanted to compare their performance. So in this next next few lines will be concentrated on this following: logistic regression without PCA, logistic regression with PCA, KNN without PCA, which has its hyperparameter tuned, KNN with PCA, which has its hyperparameter tuned, 3-layer CNN, hyperparameter tuned using grid search, and the following. So confusion matrix, this is KNN without PCA, which has its hyperparameter tuned, and this is the confusion matrix. After that, I will go through the conclusions and the observations that I had while performing, which is in the performance comparison is in the documentation. I have clearly stated with a table, with a the table which compares the different models. So performance comparison was achieved by comparing the metrics of all 7 models against the testing dataset, which has got 1000 images. I've captured the weighted average of accuracy, precision, recall, and if1 score below so that it helped me compare. Graphs, I captured graphs and matrix also. So the conclusion is the KNN was the slowest of all the algorithms that I have done here. KNN performed very slower as the dataset increased and the number of neighbors increased. Number 2 is 3-layer. CNN was the best performing algorithm of all metrics. Number 3 is hyperparameter tuning, which was very time consuming, which allowed me to achieve much better result. And number 4 is PCA based dataset, which allowed for much faster model training compared to the original dataset at the cost of a very small loss in the performance. I was able to perform all the training in the cloud except the hyperparameter when I was doing hyperparameter tuning, because in case of cloud, when I'm running the code gets timed out. The runtime is only 1 hour. After that, the it just kept timing out. So these are the observations that I had on the FashionMNIST dataset. Thank you.